Question 15 of the May 2018 AS Paper 1, Edexcel. So last question now, and we're on to an area under a curve question, so integration question. The most important thing with these questions is before you start integrating anything is you really need to look at the diagram and sort of think about how you're going to work out that shaded region. And part of that shaded region is an area under a curve, and part of it is something else, and you really need to split your diagram up so you can really visualize exactly what you need to do. Okay, and the key thing here with this question is to drop a line down on the diagram there. Okay, so we're really splitting this up into two things. Okay, one thing is just a simple triangle, so we don't need any integration for that. Okay, and then the other part, which I'll just do in a different color, this part here, this is an area under a curve. We're going to integrate this function here between 2 and some other number that we need to find out. We need to find out what this number here is, okay? And that is the x-coordinate of the point P, and we've been told it's 4. Okay, so sometimes you need to work it out, sometimes it will be given in the question. Okay, let's do that bit first. Let's do the integration between 2 and 4, okay, and then we can deal with the triangles completely separately. Okay, so we're going to integrate, well, 32 over x squared, we really want to change that to a negative power. Okay, and then we can just copy the rest in, 3x minus 8. Okay, and we're going to integrate that between 2 and 4. Okay, so let's do the integration. So the way I do that, I tend to just copy this number at the front. I'll raise the power, divide by the new power, and it looks messy, but I'll tidy it up on the next line. Okay, next one, again, copy the 3, raise the power, divide by the new power, and then when you've just got a number, okay, you just pop an x on the end. Okay, now normally you put plus c on the end when you're doing integration, but that's called indefinite integration. We're doing definite integration here to put some squared brackets on, and that's you can transfer your numbers on the integral over to here. Okay, we could tidy this up, or let's be honest, most of you are going to just pop this into your calculator now. We just need to enter x equals 4 first. Okay, so this first one, it's going to be negative 32. I'm going to do it without a calculator. Negative 32, well, 4 to the power of minus 1 is the same as a quarter. So it's going to be this. And then the next one, 4 squared is 16, times 3 is 48, divided by 2 is 24. And then minus 8 times 4 is minus 32. Okay, so we do that number separately. Putting them in brackets really helps you separate it. Okay, so now we're going to subtract, and now we enter the number 2. Okay, so same again, I'm going to get minus 32, but over 2 this time. Then I'm going to get 2 squared is 4, times 3 is 12, divided by 2 is 6, and then minus 16 on the end. Okay, now as I say, really, I would just say pop all of this into your calculator. So what have I got there? Minus 8 plus 24 is 16 minus 32, so that's minus 16. And then we've got minus 16 plus 6 is minus 10, minus another 16 is minus 26. And that should make sense that I've got minus a minus, because you can see from the diagram that this should be a positive number. Looks like it's 10. Okay, so this area, blue area here, is 10. Let's do the red area in a completely different method. It is just a triangle, so we will need to know what the base of the triangle is, and we need to know what the height of the triangle is. Okay, well, the height of the triangle, well, that's just the y coordinate of the point P. Okay, and we've been given that. We don't need to work it out, it's been given. Okay, and then we need to know what this coordinate here is, and we need to know this one, which I should have probably put on the diagram. We already know that that's 4. So you can see we're just missing one number there, and that's where the line L meets the x-axis. Okay, so the next step then is to try and get an equation for the line L. Okay, so the line L is normal to C at the point P. Okay, we've got quite a bit more work to do here then. We're going to actually find the gradient of the line that is tangential to the curve C. Okay, and that should make you think, it's a differentiation question. So I'm going to go ahead and differentiate this function. Okay, so again it's 32 to the power of x minus 2, so bring the minus 2 down to the front, reduce the power by 1, differentiate the 3x, is just 3, and the minus 8 disappears. Okay, and the gradient of that tangent then, at that point P, we need to substitute the x coordinate of P in there. So at x equals 4, we're going to get minus 64 times 4 to the power of minus 3 plus 3, and again you can just put this in your calculator. 4 to the power of minus 3 is 1 over 64, so this is actually just minus 1 plus 3, which is 2. Okay, and it kind of looks about right from the diagram. It's a positive gradient, gradient's 2, that's great. So we now know that the gradient of our line L here is the negative reciprocal of this. Okay, so the gradient of that line is going to be minus a half. We're part way to finding the equation of this line. It's going to be y equals minus a half x plus some value c that we don't know at the moment. That would be the point where it intersects the y-axis. But in terms of finding it, we just need to plug in any point that we know on that line, and we know that the point P lies on that line. So we can plug in those coordinates. So the y-coordinate is 6 and the x-coordinate is 4, and you can see as we plug that in we're just going to get some numbers, so it allows us to work out what c is, and it looks like c is going to be 8. And again, if you look at the diagram, okay, it looks a sensible number. Yeah, the point P was 4,6, this is 8, it looks correct, doesn't it? Okay, so our equation then is y equals minus a half x plus 8. Okay, now we didn't really want the full equation. Really all we wanted to know is where does that cut the x-axis? Well, it cuts the x-axis when y equals 0. So we plug in y equals 0 and rearrange this, and you should get x is equal to, it's going to be 16, isn't it? Okay, and again that kind of looks a sensible number on the diagram. Okay, so can you see how I've kind of drawn this extra triangle out over here? Okay, this triangle goes from an x-coordinate of 4 to an x-coordinate of 16, so the length of it is 12, and then I want the area, so a half base times height, so the area of the triangle is 36. Okay, so our final answer then would be the area of the triangle 36 plus the area that we worked out over here. 36 plus 10 is 46. What's quite nice about this question is that it's a show that question.